Hello everyone, Doug Simonian over at New York Metro Weather with your latest video discussion on this chilly Saturday evening. This video, well, I'll try to make it quicker, but you know me, I do talk a lot, but this will be primarily focused on being a quick update on the models and what the trends are anyway on the models for the potential snow event for next week, and why some models have trended away from a snowier solution, but why it's still not too far away from being a solution that could be a lot snowier. So we'll take a look at, this is today's European model at 500 millibars. This is the WSI Model Lab. We see this is valid for Sunday morning. We see that there's a large ridge spike in the west. That's often critical for getting an East Coast snow event. It always starts, well, not always, but almost always starts with a large ridge spike out west, because that leads to the mean trough setting up in the east, and also can allow, if the ridge is amplified enough, to allow strong polar shortwaves to dive due south from the Arctic into the U.S., and that is what we will be seeing occurring on Sunday into Monday, with a very potent shortwave entering the U.S. Actually becomes closed off and kind of cut off from the atmosphere pretty quickly. This is closed 500 millibar low near Minneapolis, actually. But you still see the high heights from the ridge still rolling over the top. This will allow the shortwave to continue to dive southward. There's also this lead energy running out ahead of the storm, which may prevent amplification initially. As you scroll through time even further, it almost looks like a flat, elongated bowling ball look at 500 millibars, as you see the shortwave gradually deepen and elongate. There's an elongation because there's a little bit of a squeeze play between, you see these higher heights almost pushing down from north to south. That tends to try to push, the back end of the shortwave from north to south. But then you also see, once this lead energy amplifies and moves out of the area, the ridging downstream amplifies as well. So you get kind of a squeeze play between the upstream ridging with the downstream of the PNA, and then the downstream ridging in the western Atlantic region. So you get the storm to tighten and compress aloft, which can be a good thing for a snow event, but also could be a bad thing depending on where exactly the core of the vorticity and the core of the 500 millibar low sets up. And that's what we'll be talking about at length in this video. We see that the shortwave trough, it does continue to elongate and amplify. It's actually a really tight wavelength with the ridge, trough, ridge. So that tightening of the wavelengths is important because this ridge actually rolls over to the east a bit. And the ridging does end up a little bit east of what you'd normally expect for a snow event, but because of the wavelengths tightening, you still get a chance of a storm heading up the coast. But notice how this vorticity is kind of strung out and elongated. So you're actually kind of focusing some positive vorticity advection verbatim downstream of the trough rather than at the base of the trough. If we were to consolidate the vorticity more at the base of the trough, then most of the forcing mechanisms for lowering pressures and lift would occur right downstream of this base. And then you can get pressure falls and precipitation to develop in the central and northern mid-Atlantic, and then a low pressure area near that, and then heading up the coast, which could still certainly happen. But the thing is, if the vorticity is not necessarily focused there, and it's also a big area of focused vorticity to the north as well, then you're also getting positive vorticity advection just via this vorticity heading eastward into the area of no vorticity. So because of this positive vorticity advection also occurring pretty far north, because it's not centered at the base of the trough, you're getting lift and precipitation and pressure falls due west of the area in Pennsylvania and parts of upstate New York. And that leads to a primary low pressure system developing in those areas as well, which takes away the emphasis of the low pressures developing further south. And we can see that transpire at the surface. The storm does try to consolidate its vorticity at the base of the trough as the storm progresses, but at this point it's still a little bit too positively tilted, and the lead energy already kind of lowered the emphasis. But the idea of the vorticity initially being elongated, but then consolidating quickly towards the base of the trough is the evolution that we want to see for a snow event. But even still, on this solution verbatim, look, this vorticity is strung out and elongated. So although you're getting some positive vorticity advection at the base of the trough, because yes, at this point, the base of the trough does have more vorticity than prior, and you're advecting into area of no vorticity, you still have the strung out area of vorticity to the north, so you're also still emphasizing lowering pressure to your northeast rather than to your southeast. So it's kind of a battle, so to speak, and the storm doesn't really take on its own entity. But if the vorticity were to have become more quickly consolidated at the base of the trough, the lead energy would weaken and the focus would shift to the south and into the mid-Atlantic, and that's how you get your snow event. So at the surface on the European model, we see that the primary low pressure system in western PA and upstate New York out ahead of the lead strung out area of vorticity in the Great Lakes and in the upper part of the Adirondacks. So that as you scroll through to 90 hours, you get some pressure falls due east of that rather than at the base of the trough, where ideally you'd want your shortwave amplification taking place for lowering pressures. So you get this lead wave of low pressure that gives some light to moderate snow for the interior, but with the initial lowering pressures to the west and northwest, it actually leads to some easterly flow for the coast. So this would actually mean some light rain for the coast with some light to moderate snow for parts of the interior. And then that storm kind of doesn't really get the strength in all that much because it's sheared out. And then we see the secondary area of lowering pressures off the mid-Atlantic coast that does try to blossom, but again, there's a competing battle, as we talked about at 500 millibars, because this lead low pressure area is still trying to develop, and the secondary low pressure area doesn't become its own singular entity, and the area of low pressure actually becomes one large closed isobar, so it doesn't become its own singular entity. But again, if we were to consolidate the area of vorticity at the base of the trough quicker, then the storm would become its own entity and you can get a coastal wave delivering significant snow. This was last night's European model, which showed more of the evolution that you'd want for a snow event. The lead wave, the lead energy got out of the way quicker. It was just some elongated low pressures, but nothing was really closed. And then allowing the second area of low pressure developing at the base of the trough to become more of its own entity, with the pressure falls more focused on the mid-Atlantic area. You even see already a low pressure forming off the Carolina coast. And that leads to an area of moderate to heavy snow, actually. This was last night's European model for the coast, if that were to have been correct. And we can even look at 500 millibars on last night's European model. Look how much more focused the energy was at the base of the trough, valid at 6Z, so early Wednesday morning. Whereas on today's European model, at the same time frame, see, it didn't dig as much, right? Look how much the energy was focused at the base. This is last night's, today's. Last night's, it's dropping down to the base of the trough, so that's where the most of the vorticity is, so you get more pressure falls and precipitation further south. But on today's European, the energy is focused a little bit more northward, and it's not as strong at the base. Thus, the energy ahead to the north can take a little bit more precedence and take away emphasis from the second shortwave. So that's what makes the setup a little bit fickle, because it's going to be a battle between the lead wave and the secondary wave as far as what's going to have more emphasis for a snow event. This was today's GFS model from this afternoon. It does show a shortwave trough trying to amplify at its base, but this isn't really that far south, and the highest values of vorticity are actually still located Tuesday night in northwestern New England, upstate New York. So the lead wave still takes precedence, and then later on you do try to get more vorticity consolidating at the base, but this is still too strung out for a major snow event, and the lead wave still has too much precedence, though a coastal wave does develop well offshore. the one thing to note is that this was the 18Z run on the GFS. The prior run, the 12Z, had the emphasis further northeast. So if this trend were to continue, you could see the GFS gradually trend toward a snowier scenario. See, this is the 18Z run. The vorticity was focused more southwest and towards the base. See that maximized area of vorticity there? But then at the 12Z run, it all was kind of elongated into one piece with the northern stream and further northeast and more progressive. So, and the 6Z run was even more progressive than that. So if this were to continue to trend towards holding back a bit more, see even 84 versus 90, you see that the trend more clearly. The energy at the base of the trough was strung out and not strong at all. And then at 18Z, it holds back a bit more as the energy at the base of the trough is stronger. But even still, this would only be a trend you'd want to see. This solution isn't good enough for a snowstorm. But if this trend were to continue, it'd be potentially a shift back towards the snowier solutions. And we see the GFS at the surface. We see the lead wave give some light snow to the area on Tuesday. And then you see the secondary wave try to develop on Wednesday morning into Wednesday afternoon. But then the parent storm heads offshore. Though compared to the last run, the 12Z run was further offshore. The 18Z run was a little bit closer to the coast because of those trends we talked about. But again, it's still not nearly enough for a significant snow event because it's still too elongated and the vorticity takes too long to consolidate at the base of the trough. This was today's NAM model, which actually was a much more impressive solution. Again, this is at the NAM at the end of its range, so maybe you take it with a grain of salt. However, I do think the NAM has more value than most other meteorologists do. I think it often does pick up on trends that other models do not, but again, the NAM at the end of its range still something to take with a grain of salt. But it does show the lead wave actually being kind of weak and weakening as it heads to the coast, with the secondary wave gaining more emphasis and already overspreading light to moderate snow across much of the northern mid-Atlantic and into the New York City area as well. Why does it do that? Look at this trough. The energy is very well focused at the base of the trough, and it dug very deep. This was the 18Z GFS at the same time. It's night and day for a snow event. The energy is really digging well at the base of the trough. GFS, it's a much shallower trough. So you get this deeper trough, and look at this. Even you see this beautiful vorticity maximum at its base. So the positive vorticity advection gets emphasized in this area out ahead of it, rather than out ahead of the strung out area of vorticity with the primary low. We can see that the NAM view on my website, the 4-panel plot. You see the low pressures, the kinks in the isobars off the mid-Atlantic coast, with precipitation overspreading the area. Very cold at 850 millibars to the west, but you see a nice temperature gradient as well. And then the jet, you even see a dual jet region. You see the left, you see this jet maximum in the Tennessee Valley and parts of the mid-Atlantic. And you see another jet maximum in northern New England. So the left exit region of this jet and the right entrance region of this jet co-aligns with the northern mid-Atlantic into the northeast. So that's a nice dual jet structure for a snow event. And then, of course, you see at the base of the trough at 500 millibars, the vorticity aligning itself very well. So this is a good 4-panel plot if you want a snow event. Another view of 500 millibars, you see the vorticity at the base of the trough is certainly very strong, and its own singular feature at this vorticity area ran out ahead, allowing this to become its own singular feature. And then again, the jet, you see it very well. The jet streak in the Tennessee Valley and northern mid-Atlantic, and the second jet streak in northern New England. So if you were to get these dual jet regions together, that would also help for a snow event. Alright, so that about does it for this video. And as you can see, there are certainly ingredients there for a potential potent snowstorm, but with potentially too much emphasis being laid on the lead wave because of strung out vorticity, it becomes a fickle setup that it's hard to have high confidence in a big snow event at this point. But certainly we'll have to be watching the trends and the models to see if we can get back to the solutions that were more consolidated at the base of the trough with a deeper digging shortwave. If we get back to those trends, then we can start to talk about a bigger snow event for about Wednesday next week. But again, the lead energy, the strung out area of vorticity, makes it hard to be confident in any accumulating snow event occurring at this time. So, alright, so we hope you enjoyed this video, and we'll be sure to keep you updated and talk to you guys soon. Take care.